Go ahead, Dr. Greiner, please.
All right. Well, good afternoon / evening, everyone. I'm Scott Greiner at Virginia Tech. Wear several hats here at Virginia Tech. I'm primarily extension specialist in beef cattle and sheep, actually, and do a little bit of goat work as well, and have some graduate students and teach class and primarily do extension work. But thank you for the opportunity to join you this afternoon and this evening and discuss a little bit on ultrasound. It's a topic that I've been pretty involved with throughout my career. Actually, my PhD work at Iowa State a while back. I won't date myself that far back, but we did some of the initial work with ultrasound in beef cattle, and actually was part of the group while I was in graduate school that got ultrasound off the ground and as a genetic evaluation tool to make genetic progress in carcass EPDs and beef cattle. And being a sheep person, a small ruminant person myself, have kind of been involved in the ultrasound side of things for several decades now. And so it's a pleasure to get to talk and reminisce a little bit and talk a little bit about this topic with you this afternoon. Hopefully, my slides are showing up. If somebody can give me
Yes, they are.
Okay, good. Very good. So I've been asked to address ultrasound as a tool related to carcass traits in small ruminants. I'll be honest, we're gonna concentrate probably in sheep. A lot of what I have to say will has some application to goats. Unfortunately, we're probably not as structured when it comes to goats and ultrasound technology in terms of how we use that technology in the industry. We're quite a bit more advanced on the sheep side, which largely, I guess, is an extension of what we've learned on the cattle side, as well as some other species. But we're going to kind of cover the waterfront this afternoon, and very importantly, I want to make sure that if we have any questions, that we're able to answer those. So put those in the chat box, and we'll do our best to get those addressed. So I thought I'd just start a little bit and talk about what is ultrasound, and I think a lot of us are familiar with ultrasound as a technology. It's not anything new, and to be candid, we've adopted what we utilize in livestock species from human medicine. And so that machine on the lower part of this slide, that's an Aloka 500, which was one of the early ultrasound machines that we used in humans for various diagnostics and various medical uses. And we adopted that for livestock. That was kind of the gold standard, probably 30 plus years ago. But ultrasound has come a long way since we first started using it in the mid 80s. And ultrasound, in very simple terms, it uses high frequency sound waves. Those sound waves are not audible or not detectable by you and I as humans, but those sound waves travel into the tissue. And each time there is a change in density of the tissue, we get a reflectance. And when that's reflected back, those sound waves are picked up by what we call the transducer, and then the technology turns that into different shades of gray. And so when we look at an ultrasound image, as you kind of see on the bottom picture here, those different shades of gray identify boundaries or borders of tissues of different density. It's our job then as technicians or as trained scientists to know anatomy and understand what we're looking at. Is that muscle tissue? Is it fat tissue? Is it bone tissue? Is that an organ? Is that a fetus? What is that? Depends on what the application is for that particular technology. And so there is a lot of human involvement in this. And I think that's important to understand as we talk about the technology itself. So use of ultrasound in live animals to predict carcass traits depends on several factors. One is the technology has got to provide an accurate, precise, and repeatable estimate of the trait that we're trying to estimate, in this case, carcass trait. So does the technology ultrasound, does it accurately, precisely, and repeatably predict loin muscle size or fat depth? Secondly, are the traits that we're measuring, are they heritable? In other words, is there a genetic component that we can exploit and therefore take these measurements and make genetic improvement? Are there favorable genetic correlations between the ultrasound measure that we can use in seed stock animals, in this case rams, or even ewe lambs, and the carcass traits of their progeny? Is there a relationship there that's favorable genetically? And then finally, is there genetic variation in the population that we can exploit to make genetic progress? So if there's no difference in loin muscle size between animals, we can't change that. Fortunately, as we all understand, there certainly is. And so if we can measure it with some accuracy and precision, and we utilize those records in a fashion that translates to genetic differences, we know they're heritable, we can make genetic progress in these carcass traits. So fortunately, all these things are working in our favor. So this is some images that'll be familiar to you, but really what we're doing is using ultrasound to interface the 12th, 13th rib interface on the sheet. And so the lower right corner here kind of shows you an image of a ribbed lamb carcass, which is actually, if we were measuring these traits on the carcass, whether that be fat thickness, loin muscle size, that's where we would rib the carcass, and that's where we'd go in and do those carcass measurements. Okay. That ultrasound image on the left that I've shown you the boundaries for replicates that. And so it's our job then, as trained professionals that do ultrasound, to distinguish where those borders are. Where's the loin muscle? Where's the fat thickness? We're going to talk about loin muscle depth a little bit. That's here in the blue, which is simply the depth of the loin muscle itself. There's a relationship between loin muscle depth and loin muscle area. They are not perfectly correlated, but there is a strong relationship that we can use one as the proxy for the other. So that's a very good example of an ultrasound image that we might get, where those boundaries are, and kind of what it looks like. So why is this important? And maybe to back up, it's probably a little beyond the scope of my discussion today, is carcass traits in general. But when we look at carcasses and where the value is, most of that carcass value is in the hind saddle, of course, which is the loin and leg. But if we go even more specific than that, if we look at the loin muscle itself and its component in the rack and in the loin, that represents about 36% of that carcass value, but only about 18% of the weight. And so a relatively small portion of the carcass really determines a lot of the value. And so if we can enhance that, make sure it's of acceptable quality, size, fatness, etc., we can enhance the total carcass value in that animal. So what we're measuring is here and right in the middle, right there where it's ribbed, we're measuring loin muscle size and fat depth as a proxy for total carcass composition. But the reason that we use that muscle when we use that region is for several reasons. One, it's easy to get to, but secondly, it also has a pretty strong relationship with total carcass value. One of the important things we noted on the previous slide is that these traits are genetic. In other words, are they heritable? And here's a list of various sheep traits and their heritability. If we want to categorize those, we generally think about reproductive traits as being lowly heritable. And when we say lowly heritable, that's probably 10% or less. What does that mean? That means that approximately 10% of the difference that we that we can measure or visualize between animals is due to genetics, and the balance of that is due to environmental factors. So as we get to moderately heritable traits, like carcass traits, ribeye area, and fat thickness, they're very similar to some of our weight traits like weaning weight and post-weaning weight, actually a little higher, but they are more heritable than reproductive traits. And then we think of things like fleece traits, which are very highly heritable, excess of 0.4 in terms of heritability. So as we measure fleece traits, lots of the difference between animals is genetic, and a relatively smaller portion relative to some of the other traits is due to environment. This is really important because we need to have genetic control if we're going to be able to make genetic progress. The good news is that carcass traits are moderately to moderate to high heritability. And so if we can measure them with some accuracy, we can select on that and make genetic improvement. Okay, let's talk a little bit about ultrasound accuracy. And what do I mean by that? What I mean by that is, what's the relationship between the ultrasound measurement or the estimate that we obtain using ultrasound and the actual carcass measurement that we might measure in the cooler? Okay. How do they rank? What's the repeatability? I think from an interesting standpoint, we consider the carcass measure to be the gold standard, if you will. In other words, we assume that that is true. I'll share with you that as someone who spent a lot of time in a cooler and measured lots of carcasses, that carcass measurements are not without error themselves. And so, it's true that the carcass measurement is the gold standard, but there's some inaccuracy introduced in terms of measuring carcasses as well. Anytime we do it, there's human error. And so that is not done with 100% precision either. So we can measure that lots of different ways, and I don't want to get too deep into kind of the academic part of this. But carcass traits are what have value, right? That's what consumers care about. That's what processors care about. They're the traits of economic relevance. We observe those in fed animal or animals that we slaughter or harvest. You might think of ultrasound traits as being indicator traits of carcass traits. While they are certainly predictors of, they are indicator traits of what's going to happen in the carcass. And of course, the challenge that we have is we look at breeding stock. The only way to get a carcass measurement is to have a carcass, right? Which requires that animal be harvested. Well, obviously, we're not going to do that to seed stock that we want to keep and use for breeding purposes. So we have to use these indicator traits, okay? But the goal is to have a high correlation between those and strong phenotypes associated with those carcass merit traits. Okay, there's lots of ways we can measure this. We do this in the industry. We do it in the sheep industry. We do it in the cattle industry. We do it in the swine industry. We can look at correlations. We can look at bias. In other words, how far are we off? We can do things like standard errors of prediction. Won't go into too many of those details other than to say, why is ultrasound not 100% accurate? Okay, there's lots of reasons for that. One of those is the technician. In other words, the person running the machine. Okay. There's a couple sources of error: how they collect the image, and then secondly, how they interpret the image. In other words, when they look at their machine and they draw the boundaries for fat thickness, they draw the boundaries to measure muscle area or loin muscle depth. Okay, are they doing that precisely? Are they doing that accurately? Those are both areas that error can be introduced. We know there's differences between animals. In general, animals that are fatter are more difficult to scan and we're less accurate. We have issues with hair sheep in terms of image quality. And so there's differences between animals. there's differences between machines. There's several different kinds of ultrasound machines out there, some older, some newer. There's different hardware, there's different software. All those can be potential sources of error. And then there's environmental things, temperature, weather, other things. So all these things coupled together can cause inaccuracies. But at the end of the day, hopefully we can make those measurements with enough repeatability and enough precision that they do the job for us. So as we look at accuracy, maybe to try and put that in layman's terms, if you will, on this table, if you compare ultrasound data to carcass data on the same animal, most of the literature would tell us that those correlations are somewhere between 0.75 and 0.85, okay? Another way to say that is that approximately 2/3 of the time, or 70% of the time, we can be within a tenth of an inch in terms of fat thickness, and within a quarter of an inch as it relates to ribeye area, okay? That will depend some on technician, that will depend some on technology, it will depend some on the animal. But in general, ultrasound is a acceptably accurate predictor of the same traits in the carcass, and we've got lots of literature that backs that up. So with that, guys, it's time for question number 1.
Okay, I will launch it. Oh, there is the questions that people start answering. We have 60 people that have answered. Okay, somebody else? Okay, here are the results.
Very good. The correct answer is moderately heritable. Those of you that said highly heritable, you're not terribly wrong there. I would kind of characterize them as moderately high heritability, which means that a significant portion of what we can measure on an animal is due to genetic differences. Lowly heritable traits like reproduction, it takes much longer to make genetic progress. So kind of as we covered, that's the good news on carcass traits, is that if we can measure it and we can use those records, we can make progress genetically.
Okay, thank you.
Thank you. Is there any other questions in the chat box?
Gabriel?
I'm not seeing any so far.
Okay. We'll keep rolling along. All right. So let's delve into this topic after we kind of got the basics behind us and some background information. So why would we be interested in ultrasounding sheep or goats? I think there's 2 principal reasons. One is we can use ultrasound as a proxy for carcass data. And what I mean by that is if we don't have the opportunity to actually measure the carcasses in the cooler, a good example of that is a carcass show or a carcass contest. Perhaps we don't have access to the harvest facility. Perhaps we don't have the expertise to measure a carcass. We can use ultrasound instead on the live animal to predict those traits, rank those animals, etc. It can serve as an objective measurement of body composition. So we use a lot in research to help us do that for body condition, for muscle mass. We might use it in that context for marketing purposes, etc. And the third thing I threw in there was just the educational value of it. So helping us all understand, location, anatomy, where are carcass traits measured on the live animal, etc. The other one, which is probably of more interest to us from the context of this Zoom tonight, is that we can ultrasound or scan breeding stock and use ultrasound as a tool for genetic improvement of carcass traits. Okay, so we can scan those animals for the relevant carcass traits, utilize that data in a couple different fashions, which we'll talk about. We can use the actual measures that we adjust to a weight constant basis, or we can use those measurements in the form of EBVs and a stronger genetic tool. Okay, so we'll concentrate on that as we move through. So who ultrasounds or who does this scanning? Obviously, not all of us have access to an ultrasound machine. Given their cost, it's probably cost prohibitive for most of us to own one. And so we collaborate with folks out in the industry that are doing that. So actually, the National Sheep Improvement Program conducts training schools and also conducts certifications for folks that are doing carcass ultrasound. So those trainings are often held in conjunction with laboratories or centralized labs that process images for the beef cattle industry, and hold those to train people that might have an interest in ultrasound. So anybody out there who has an interest, you could procure a machine. You could go to one of these schools to get trained how to use it. You could certify to certify your proficiency. And then you could go out and you could ultrasound sheep, you could ultrasound beef cattle, and utilize that data, provide it to producers and provide it to them for use in their genetic evaluation programs. So I've listed the website here to the National Sheep Improvement Program. You can go find more details about the background on this. But I would say there's also a list of ultrasound technicians. You can go to their website. It lists what state they're in. It gives you their contact information. So at the end of the day, if this is something you're interested in pursuing, you can go find a technician that's in close proximity to you, and work with them to do ultrasound on your animals if that's an interest. Many of the technicians that are doing small ruminant ultrasound for carcass traits are also doing other species, namely beef cattle and or swine. Okay, the reason for that, these ultrasound machines cost in excess of $20,000. And so keeping them busy and having and the ability to scan animals is really important. And so it makes sense to be diverse. Many of the folks that are doing small ruminant scanning also collaborate with ultrasound labs, centralized ultrasound processing labs. I think there's currently 4 of them in the industry, namely the beef cattle industry. And then what happens is that technician would come to your farm, they would ultrasound your sheep. They would actually send the images to a centralized lab. The centralized lab is the location where the images are interpreted and the measurements determined. The lab would then send you back results or measurements on your animals. So it's another partner in the process, and that's required in the beef industry. It's currently not required in the sheep industry, and so some technicians actually do their own interpretations, but some do use a centralized lab. So we're interested in scanning breeding stock. When do we do that? How do we do that? Some of the details. So we typically do this sometime post-weaning when those animals are around a typical market weight. And the reason for that is that we're trying to emulate in breeding stock what's happening in slaughter progeny. So we want to ultrasound or scan them around the same time that they would reach market weight. So depending on your breed, depending on your production system, that's somewhere between 100 and 150 pounds live weight, okay, is when we want to ultrasound. If we've got, if we live in the Midwest and we're producing market lambs that we're feeding and selling at 130 to 150 pounds, we probably want to be on the upper end of that. If we've got hair sheep that we're selling to the ethnic market, we probably want to be on the lower end of that, kind of depending on where our production system is. What's really important is that we maintain contemporary groups, okay? And you can think of contemporary groups as a group of animals that have all been given the same opportunity to perform. In other words, we want to minimize the amount of environmental difference between animals that we're going to compare. So we want those animals to be born about the same time, on the same farm, eating the same feed, living in the same barn, running on the same pasture, under the same health program, exposed to the same weather conditions, okay? So we can eliminate those variables as causing differences in the ultrasound measure or any other trait we're interested in, for that matter. We want to eliminate those variables, okay? So contemporary groups is a really, really important concept. We can only compare within ultrasound measures within a contemporary group. Couple other things. In general, if we're going to ultrasound, because we're going to do that at 12th, 13th rib, right on the top line of the animal, we're going to need to either shear or clip that region so we get good contact on the animal. We can apply lube or oil to do that. Those of you that have seen ultrasound done understand what I'm talking about. And have the right handling facilities in order to do that. So the other thing that's important, in addition to contemporary groups, is we want to adjust that data, just like we adjust weaning weight to age of dam, gender of the lamb, how it was born and raised, whether it's single, twin, triplet, etc. We're going to do the same thing with ultrasound data. We are going to adjust that to a constant weight, okay? We actually did this research at Virginia Tech and established the equations to do this. A graduate student here did that about 15 years ago. Joe Emenheiser is his name. That might be familiar to some of you that are on the call. But I'm just sharing with you here the linear adjustment, and I'm happen to use 125 pounds here. You could change that to 100 pounds. You could make that 150 pounds. I think we're pretty comfortable between that range. 125 is kind of in the middle of that. You simply plug in the data to this equation. You need to know the actual measurement. You need to know the weight. And you can adjust it to a constant weight. Then we can ratio those within contemporary group by simply taking the individual measurement, dividing that by the contemporary group average, and multiplying by 100. Okay. Relatively simple math here. Okay. That will give us results that look a lot like this. All right. This is from our Virginia ram test. We ultrasound the rams there. This happens to be 2 contemporary groups that were in the sale last summer. The fall Dorsets on the top, the winter Dorsets on the bottom. And so we've got adjusted fat thickness and a ratio. We have adjusted loin muscle area and a ratio. Notice that the ratios are only in contemporary groups. So the fall Dorsets are different than the winter Dorsets because of their age difference and because of their difference in growth and maturity. Okay. So we can compare those ratios and those measurements within the fall Dorsets or within the winter Dorsets, not necessarily between them. It's not nearly as relevant. Okay. But it helps us rank them, helps us understand which one, if loin muscle is important to us, we can place some selection pressure on that. But that would be a mechanism to use adjusted data that we get back from our scan information. I will caution you, there are some limitations to doing that, okay? That data is really only valuable or pertinent within contemporary group. So if I'm doing ultrasound in Virginia and you all are doing ultrasound in Missouri, it's really difficult, in fact, impossible, and we shouldn't try to compare measurements between the two locations because of the environmental differences. Different flock, different season, different environmental conditions, okay? And that phenotype that we're measuring is a result of genetics and environment. The environmental component is still in there, okay? We adjust for weight to try and take that out, but it's impossible to take out all the environmental component using that system. So I'd caution you on the actual records. You can utilize them within flock, within contemporary group, but doing that beyond that will be very challenging. Okay, let's go to our second question.
Okay.
I'm going to let them answer their question, but then there are a couple questions in the chat for you.
Okay.
Now we have around 70% of the people that have answered. Somebody else?
Very good. Either my questions are too easy or you guys are really good listeners. So,
I think
yes,
they are not sleeping.
it's all the above. That's right. So, contemporaries are animals that have all been given the same opportunity to perform. So they're in the same flock. They're of a similar age. They've been managed together, etc. Very good. So I'll answer these couple questions in the chat as best I can. Is there relevant data that can be used from ultrasounding a 2-year-old breeding ram? That would be extremely challenging. You know, you can ultrasound that ram certainly and get measurements. I don't know what those measurements mean, would be the challenging part. Because unless you've got a whole flock of 2-year-old rams, and then even in that case, 2-year-old rams are going to be well beyond the equivalent that we're trying to predict in a slaughter animal. So you might be able to rank them for relative muscle. I'm not sure exactly how we would use that data. And without a basis to compare it, that data would have very limited value, in my opinion. Second question was, I have a portable ultrasound and not I assume $20,000 unit. Why would that not work? I mean, there are some ultrasound machines out there that are probably cheaper than what I quoted you. Most of those that are being used in the livestock industry by professionals that are doing ultrasound as a profession, whether they're veterinarians or they're technicians that do that in multiple species, are using machines that have the capability to save images, to digitize, to etc. So there might be some cheaper than 20,000. The important thing is that it has the capability to image those tissues that we want it to. So without specifics on the exact machine that we're talking about, that's kind of my thoughts. So, I mean, there are machines that are cheaper, particularly some of the older technology, you can get cheaper than that. But it's still going to be a significant cost. Good questions. Thank you. All right. So we talked about the limitation. Let me go back real quick. There are limitations with the actual adjusted data itself. Okay. So how do we get around that? The way we get around that is to use this technology as part of the National Sheep Improvement Program, take those measurements and turn them into estimated breeding values, or EPDs, if you will. Okay. Real briefly, what are EBVs? They are a genetic prediction specifically of the genetic merit of the animal for that trait that we're interested in. Okay. This system, NSIP, utilizes individual performance data. It utilizes pedigree information. It utilizes progeny information. And through the National Sheep Improvement Program, we can take those records and we can turn them into genetic prediction values in the form of EBVs. Okay. I'll explain that a little bit more here in the next couple slides. So why does this have so much merit? Through EBVs, or estimated breeding values, we can take the guesswork out of ram selection. So we have a predictor of actual genetic merit. Okay. It allows us to compare animals from different flocks, from different environments, from different states, from different feeding programs, etc. So it gets rid of the limitations that we have with adjusted records and environment, because we're going to take the environmental component out as part of the calculation of an EBV. Okay. Therefore, it's a much more powerful tool than actual data or adjusted data, and it helps us focus on what's really important economically. Okay. How do we do this? The first step is we've got to measure the trait, right? In the case of what we're discussing tonight, that's having our animal scan, it's having ultrasound data. We can do the same with weight records. We can do the same with reproductive traits. We can do the same with fecal egg counts for parasitism. We can do the same with wool traits. Okay. We got to have measurements. We got to have data. All right. So it starts with data. Okay. Step 2 in the process is we use statistical equations to account for environmental differences and known sources of variation. In other words, we use very high-end statistics to remove the environmental component from those records. Okay. Then we include pedigree information on the animal and all of its relatives. Okay. And genetic relationships between traits, the heritability of those traits, and ultimately we isolate and come up with the genetic difference between animals and assign a numeric value to that. Okay. Hopefully the next slide or two helps us understand that a little more. So what's the power in this NSIP data? We remove the environmental differences and we utilize pedigrees, and that makes it a more powerful tool than the raw data or adjusted data or RAM test data or any other source of information that's out there. Okay. So for NSIP, we have 2 carcass traits that we measure and have EBVs for. The first one's fat thickness. Okay. And the second one is loin muscle depth. Okay. Most of us are familiar with loin muscle area. Loin muscle depth is simply the depth of the longissimus muscle or the loin muscle or the ribeye muscle. Okay. It's easier to measure than area. It's faster to measure than area. It's highly correlated with area. It's correlated about 0.7 to 0.75. So it's not 100% the same. But if we select for increased loin muscle depth, we're going to increase loin muscle area and vice versa. Okay, in general. So we can use it as a proxy for area and improve loin muscle mass. Okay. So how do these EBVs work? All right. If we enroll in NSIP, we collect the data, we submit the data to NSIP. This is what we'll get back for loin muscle depth. Okay. 2 rams with 2 different EBVs. The ram on the top has an EBV of 2 millimeters. The ram on the bottom has an EBV of 0 millimeters. Okay. These are breeding values. So half of that's passed to the progeny. So half of that goes to their progeny. So 1 millimeter on the top ram, 0 on the bottom ram. So what that means is if we breed these 2 rams to the same set of ewes, their progeny on average will be 1 millimeter different in loin muscle depth. What does that mean? Lambs out of the top ram will have bigger loin muscle areas, loin eyes, than lambs out of the bottom ram, because he has a more favorable loin muscle depth EBV. Okay, so we can use that tool to help us then in terms of making genetic improvement for muscling. We can use the same for fat thickness if that's important to us. Okay, so how might we use this tool? Well, if we go to the NSIP website, we have what's called percentile ranks, okay, for these various traits. So here's traits. These are Suffolks, the Suffolk breed. These are growth traits, birth weight, weaning weight, post-weaning or 120-day weight. We've got maternal traits over here, number of lambs born, number of lambs weaned. The ones in the red box are the 2 carcass traits, fat depth and eye muscle depth or loin muscle depth, okay? 50th percentile is average, right? That's the blue dotted line. So if we've got a ram that we can buy or a ram in our flock that we're enrolled in NSIP, and his loin muscle depth is 0.31 EBV, what that tells me is he's an average Suffolk ram for loin muscle depth or muscling, okay? If it's higher than that, he's better than average. If he's up here at plus 2 millimeters, he's in the top 10% of the breed, top 5% of the breed, actually, for loin muscle depth. He's quite good. If he's -1, he's in the bottom 10% of the breed, down here. He's not so good. Okay, so we can categorize that ram in terms of his genetic merit relative to the Suffolk breed, all Suffolks that are enrolled in NSIP, and help us make selection decisions. If I have Catons, I can do the same thing, right? Catons have the same thing. We use it in the exact same fashion. The breed means are a little different. The table's a little bit different, but fundamentally, we apply that principle in the same fashion. Just so happens that breed average for Catons for loin muscle depth is 0. So that makes it easy. If they're positive, they're better than average. If they're negative, they're below average for loin muscle. Okay, and we can use that as a selection tool moving forward. All right, question 3.
Okay, there you go.
And while we're doing this question, I just wanted to announce the winner of the raffle for this week from last week is going to be Chuck Hutchins. I believe I said that. Hope I said that right. So I will be sending you an email sometime either today or early tomorrow, and we'll get your book sent to you.
Okay, good. Congratulations, Chuck. Okay. Here.
All right. 74% of you got it correct. So the best way to utilize ultrasound data is to convert that through participation in NSIP as an EBV, right? Because those EBVs are a direct predictor of genetic differences between animals. We have limitations with measurement adjusted measurement data and ratios because they are simply confined to the contemporary group that they come from. Raw measurements would have the least value because, for example, when we look at loin muscle depth or loin eye area, weight of that animal has an awful lot to do with it. So we need to equalize weight so we can do it on a weight constant basis. So EBVs are the best way, followed by adjusted measures and ratios, followed by raw data in that order. So well done.
Do you want to comment about one of the questions or comments from Kathy Forrest?
Yeah, it says we've ultrasounded all of our county fair market lambs since 2018, where the average ribeye area was 1.75. Last year, 55 lambs were ultrasounded with an average of 3. So if I'm interpreting that right, Kathy, the average jumped from 1.75 to 3 in 1 year. I don't have the data to I don't have the information probably to completely speculate, but I would be skeptical that the population changed that much in the course of that short a period of time. And so you might have some difference there in terms of measurement bias or measurement error.
But she's saying that is from 2018 to 2024.
Oh, okay. All right. So it improved over time by using the data. Potentially. So, if that's the case, I would say that, we do a similar thing with our state fair out here. We've got carcass data that goes back 20 years. And we found that kids have done a better job selecting lambs for muscling. They also do a better job managing them. And as Nick just chimed in, yes, they're selecting better rams. So yeah, it's underlying and kind of emphasizing if it's a trait that's important and you pay attention to it and you make genetic selection, you can make progress, which I think is what you've documented. Very good. Thanks for sharing that. All right. So how do we utilize this stuff? And this might be the most important message I've got here as we kind of conclude with this last handful of slides. So I guess I challenge you all to think about what your flock goals are. And why do you have sheep or goats? Where are you trying to go? How fast can you get there? What traits do you focus on? Okay. Think about a roadmap in terms of what's important. Okay. And when we get right down to it, all of our genetic progress is going to be made through rams. Okay. What sires we elect to use and mate to our ewes is where we're going to make genetic progress for the traits that we identify as being important. Okay. So we need to concentrate on the rams. I don't want to leave you with the thinking that I don't think that ewe lambs are important and which ewes we keep are not important. That is important and how we manage and develop them. But ultimately, from a genetic perspective, all that goes back to the rams to begin with, because all those females we're going to select, they're all sired by the rams that we selected to be their sires, right? And so it all goes back to the rams is what we need to focus on. So I'd ask you to concentrate on what really matters, okay? And this seems rather fundamental, but whether we have a profit or a loss is very simply our revenue minus expenses. There's several traits that go into revenue, right? Ultimately, it's how many lambs that we've got to market and sell per ewe that we expose, and what's the value of those lambs or the weight of those lambs when we sell them, okay? On the expense side is what did it take to maintain that ewe flock throughout the year or that set of goats? And what were our production costs in terms of feed and forage and labor and efficiency to maintain the flock and get those animals to their endpoint, right? So from a revenue standpoint, there's genetic traits that we've got, number of lambs born and weaned, how parasite resistant are they, growth rate, milk production. We might put carcass value in here if we are deriving revenue from a carcass standpoint, right? We've got genetic tools like crossbreeding, like EBV selection, all those traits, okay? That's on the revenue side. On the expense side, we know that how big our ewes are, how much they milk, and how fast they grow influence our cost of production. We know that infant efficiency and longevity also influence costs of production. So we can use tools like selection for growth in milk, crossbreeding to help us offset that, okay? We know there are genetic traits related to both revenue and expenses. So our key then is to figure out which ones of those are most important to us, which traits pay the bills, okay? And that's going to be different for all of you that are on this Zoom tonight. It's different for my flock than it is for your flock, right? I think about my flock and how I derive revenue, okay? I happen to be a clubland producer, an outgrowth of my daughters being in 4-H, okay? So I derive revenue through lambs that I sell to young people to show, right? I sell a handful as market lambs, but that's not my bread and butter, okay? For most of you on the call, I would assume you're commercial sheep producers, right? You derive revenue from the lambs you sell. Some of you might be seed stock producers. You derive revenue from the value of the rams, the genetic merit of the rams that you have, okay? So thinking about what's important, what are the traits that pay the bills is really, really important, okay? Which leads me to my fourth question that we're going to kind of wind up on with the final point.
Okay. There you go. Your files.
Very good. I would answer that question as true. Very true. How much emphasis you will place on those traits is largely dependent on what your production system is, what your marketing system is, and how important those traits are in terms of your revenue and cost of production. Now, we might argue and back up, and I would agree with this, that as sheep producers in the industry, we all have a responsibility to produce a quality product. I completely agree with that statement. And so making sure that we avoid animals which are going to produce poor quality product is important for everybody, okay? But how far down the road we go in terms of selection for carcass traits will depend on what our system is. If I'm deriving revenue by selling, by direct marketing lambs or selling product at a farmer's market, or I'm selling lambs to customers that are being taken to a local processor, then for sure, you know, we've got importance in our economic model for what those carcasses are about, carcass trait wise, and certainly something we want to pay attention to. All right. That's a good example. So I'm just going to leave you with one last slide, kind of as a summary. Ultrasound's a great tool. We've just demonstrated in the sheep industry and in other livestock species, it's an acceptable estimator of carcass merit. It's not perfect. It has some limitations that we talked about, but it's a very acceptable tool to utilize. Genetic improvement for carcass traits is best done through the use of National Sheep Improvement Program and the use of EBVs. And then lastly, it's kind of up to each of us to determine the importance of ultrasound, carcass traits in our own flock or herd based on what our production and marketing system is and the value of that. So with that, I appreciate the opportunity to join you tonight, everyone. I'd be happy to answer any more questions, or if there's any discussion, that'd be great. We've got a few minutes, I think.
If you have any question, you can write it in the chat.
There's a comment from Nick just saying that chefs and food services want to have a consistent product at, 365 days, and that ultrasound can help with that.
I agree with Nick on that, which kind of goes back to my previous point. We as an industry, it's an area that we've got a lot of opportunity in. And in my opinion, I think we got to quickly identify the unacceptable end that's out there. That's the easiest way to make a more consistent product, is to get rid of those that don't fit. But we got to be able to identify them first, and so we got to have the tools to do that.
Okay, well, I think it's very interesting because people, we have heard different things about using the ultrasounds, but I think there are a lot of myths, and some people even can say, okay, I will be using in one of my animals, or in my rams, or in my box, but what is the comparison? Okay, what is the standard? So and there is no at all. Okay, so but you can go to the genetic merit, so that is different. So I think it's very complete and very integrated talk. So thank you so much, Dr. Greiner. Yeah.
You bet.
Yeah. Okay, we are going to have our following webinar next Monday about reproductive diseases, and we wait everybody for next Monday. Thank you again, Dr. Greiner. Yeah.
Thank you for having me.
Thanks, guys.
Thank you, Dr. Greiner.